Hi dear students, today we are going to see the last part of chapter 1. It's known as limiting reactant, excess reactant and percentage yield. Let's look at the calculation. Consider the reaction 2Sb plus 3I2 produces 2SbI3. Determine the limiting reactant. And theoretical yield when 120 gram of Sb and 1.20 gram of Sb and 2.40 gram of I2 are mixed. What mass of excess reactant is left when the reaction is complete? Okay, this is involving limiting reactant concept. So let us look at the calculation. How to identify a question is involving limiting reactant. First way is when they mention in the question to determine the limiting reactant. The other way is information given are basically for the reactants. When the information given involving reactants, both the reactants, then it is most likely will be limiting reactant concept. So first step, we look at the solutions. Step number 1, we have to determine the mole of Sb or antimony. That is mass divided by molar mass. Mass is 1.20 gram. Molar mass is 1 to 1.8 gram per mole. Cancel the gram. So what is the value we get here? 1.20 divided by 1 to 1.8. That is 9.85. 9.85 times 10 to power minus 3 mole. Next, we look at the mole of I2. Mole of I2 given. The mass is 2.40 gram. The molar mass is 126.9 times 2. That is 253.8 gram per mole. So cancel off the gram. 2.40 divided by, then I get 9.46. 9.46 times 10 to power minus 3 mole. So I have calculated both the moles of the reactant. The mole of Sb and the mole of I2. Now we go into the limiting reactant concept. So we say here, from the balanced equation given. From the balanced equation given, we can see here 2 mole antimony react with 3 mole I2. So we have 2 moles here. One is the mole for Sb, one is the mole for I2. These both moles are known as moles available. So to calculate, we have to choose one of these mole. Let's say I choose mole of Sb. So 9.85 times 10 to power minus 3 mole Sb. If we use 9.85 times 10 to power minus 3 mole Sb, how many moles of I2 are required or needed? So how is the calculation? 9.85 times 10 to power minus 3 divided by 2 times by 3. Okay, let me calculate. 9.85 exponent 3, negative 3, sorry, divided by 2, multiplied by 3, I get 0.0148. 0.0148 mole. This is the mole of I2 required. Mole of I2 required or needed if I use 9.85 times 10 to power minus 3 mole of antimony. So the next step is we have to compare. Compare mole I2 available with mole I2 needed or required. So to make it easier, we can write the numbers. Mole I2 available. Where can I find this? It is here. 9.46 times 10 to power minus 3. How much mole of I2 needed? If I use 9.85 times 10 to power minus 3 mole of SB, I need 0.0148 mole of I2. Now the mole available is less than the mole needed. I need 0.0148, but I only have 9.46 times 10 to power minus 3 mole. That means my I2 available is less. That means, conclusion, I2 is the limiting reactant.